Hello guys, today I want to cover last year's IB exams. As we can see, this one is from November last year. So let's start. So the first question asks us about the derivative of the function in x equals -1. So what we can do is just take a derivative of this function using chain rule. So it would be e to the x squared plus 1 times the derivative of x squared plus 1, which is 2x. So equals 2x times e to the power x squared plus 1. And now we can just plug -1 and we will get -2e. So the next question asks us about the coordinates of the center of the circle, the radius of the circle, and the exact volume of the cone. So let's begin with the center of the circle. It will be on the intersection of the height and the diameter AB, and it's a midpoint of AB. So we can just write it like this. So you can just find an arithmetic mean of points A and B. And this is the answer for the first question. The next question asks us about the radius of the circle. Basically, we need to calculate the length of AO or BO, don't really matter. Let's stick to AO. So our radius is equal to AO, and it's a square root of the following. Basically, we need to square the difference between coordinates of the point O and point A. And then we need to take square root of that sum. So this thing equals to square root of 4 plus 1 plus 4, which is 9, which is 3. And this is the answer. And for the last question, you just need to find the volume of the cone. So as we all know, the formula of the volume of the cone is 1/3 PR squared over H. And as we know R, we just need to find an H, which is equal to VO. And again, we just need to find a length of VO So this thing equals 0. This is 16. This is 4. Hence, VO is square root of 20, which we can write as 2 square root of 5. And then volume equals 1 over 3 pi 3 squared times 2 square root of 5. This cancels out, and we get 6 square root of 5 times pi is our answer. The next question asks us to show this equality. So first of all, let's open the brackets, and I want to put 1 over 4 to the front, so this 2 to the front, so it's 2 squared, which is 4. And I'm gonna multiply this bracket by 1 over 4. And I don't want to cancel out these two, but as we can see, this and this we can add, and it will give us 1 minus 2 over 4 is 2 over 4. And this is also divided by 4. And the last thing, we can just do the same thing to the right hand side. Again, I want to put 1 over 4 up front. And as you can see, this is basically the same as this one. I just need to multiply by 1 over 4. That's it. And the second question asks us about find an expression for the area of the triangle. So, and also it's right angled. So what we know about right triangles? Well, the area of a right triangle is 1 over 2 AB. And in our case, A is just, well, it's just A, and B, it's A squared minus 1 divided by 2, and hypotenuse will be this one, but we don't need. And we can just We can bring this 2 to the front. And we can multiply by a. And this is our final answer. So the next question asks us for an expression for the function when we're given a derivative of this particular function. And as we all know, f of x is equal to the integral of the derivative of that function plus some constant c, which is why we are given this point to calculate this constant. So basically we need to integrate 6x divided by x squared plus 1. We can do this by just simple u sub. U equal x squared plus 1. Then du is 2x dx. And then we get 3 divided by u, which is equal to natural log of u, and 3 is put up front. Of course, plus c. And we can put x squared plus 1 instead of u. So as we know, when x equals 1, y equals 5. So, and we can write it, we can put x equals 1 into this function plus c, and it equals 5. Let's solve it for c. And c is equal 5 minus 3 natural log of 2. So our final function is 3 natural log of x squared plus 1 plus 5 minus 3 natural log of 2 natural logs using log property as x squared plus 1 divided by 2. And this is our final answer. The next question asks us about the value of alpha and the value of p. So let's begin with this observation. When if 3 plus I is a root, then 3 minus I is also a root. So what we have is this equation has 4 roots: 3 plus I, 3 minus I, alpha, and alpha squared. And the product of our roots is equal to 80. So we can write it as follows. 3 plus y times 3 minus y is 9 minus e squared. But because I squared is minus 1, it's just 10. So 80 equals 10 times alpha to the third power. Then alpha equals 2. How to find the value of p? we can just say that the sum of our roots is equal to minus p. So just write out all our roots. This I cancels out. This is this is of course 2. 2 squared, of course. And this is equals 12. Then p equals minus 12. On to the next one. So we need to determine the value of if A and B happens, if there are independent probabilities, independent events, we just need to multiply those probabilities. And this is our answer for the first question. The second question asks a minimum possible value of this event. And what we need to consider is, because probability of A plus probability of B is equal to 1.1, which is greater than 1, which would be a contradiction on its own, because the sum of all probabilities is equal to 1. So the minimum probability of this event should be at least minimum should be at least 1.1 minus 1, which is equal to 0.1. And the third question asks us about maximum possible value. So the easiest way to explain this is if event A happens, then event B also must happen. So the subset of A is contained in subset of B. Let's give an example. So imagine that event A is getting a 7 on the IB exam, and the probability of B is getting at least 6. If you get a 7, then of course you got at least 6, because 7 is more than 6. So the maximum probability would be just the probability of the event A, which is equal to 0.3. On to the next question. So we need to show that this function has no local maximum or minimum. So basically we need to show that no x and y exists on this interval such that the derivative of this function equals 0. So first, let's open the brackets. Then let's differentiate both sides with respect to x. We will use implicit differentiation, and in the case of x squared, y squared, we will use a product rule. And this simply applies power rule, and this is differentiation. And as I said earlier, the derivative of this function should equal 0. So dy to dx is 0. This and this cancel out. And what we get is 2x y squared equals 8x. We can just cancel out. Y squared equals 4. Y is equal to plus minus 2. So this function has a local maximum or minimum when y is equal to plus or minus 2, but our interval for y doesn't include those points. So because it doesn't include them, we can say on the interval from minus 2 to 2, no local maximum or minimum exists. For the next question, consider, so we have this function f of the x is equal to cosine x minus k. So the first case, k is equal to pi over 2, and this is just a sine of x. So what we need to do is just sketch the graph. So the inverse of the function exists only if for specific value of x we have only one value of y, and as we can see, this is true only for this segment, because from pi over 2, this point, for example this point, have the exact same value as this point. So our answer would be a is equal pi over 2. For the next graph, let's just sketch a cosine graph this time. But shifted by pi, so it would look like this. Because cosine of minus pi is equal to minus 1, and that's why we are starting from this point. So, and this is pi, this is pi over 2. So what we can say is, again, we have on an inverse on the interval from 0 to pi right here, because from pi, again, for example, this point has the exact same value as this point. So our A would be just pi. And for the last question, let's also sketch a graph of the cosine function. I will give you one specific example and we will make a conclusion based on this example. Let's make it like this. Okay, so if x is equal to k, then it would be cosine 0 is 1. So this point is k. And as we can see, also x is greater than 0. We can only make an inverse from x0 to this minimum when cosine is equal -1. And it happens when x is equal k minus pi. So this is our answer for this question. The next question asks us to solve this differential equation using this particular substitution. So let's differentiate both sides. We need to use a product rule. dy dx equal to and let's put it in our initial equation. And let's substitute all y's. And let's open up the brackets. And we can cancel out x squared. And what we have is v plus x dx dv dx is equal to v squared minus 2 divided by v, which is equal to y minus 2 divided by v. And we can subtract those v's. And what we get is x dv dx is equal to minus 2 divided by v. Let's bring always v to the left side and always x to the right side. So what we're gonna end up is v dv is equal minus 2 dx over x. Let's integrate both sides. It will get us v squared divided by 2 is equal to minus 2 natural log of x plus some constant c. we can substitute for the y divided by x. Let's calculate the constant c when x is equal to 1, y is equal to 2. So we will get 1/2 times 2 squared is equal to minus 2 natural log of 1 plus c. This is 0, this is 2, so c is equal to 2. And our answer for this question would be y squared is equal to 2x squared times minus 2 ln x plus 2. The second question is much easier. We just need to calculate when the derivative is equal to 0. When it happens, it is y squared minus 2x squared divided by xy, which is our equation for the derivative, is equal to 0. And y squared is equal to 2x squared. Y is equal plus minus square root of 2x. And this is our values for m. Let's move on to the next question. So first of all, we need to find the roots of the equation. Let's begin and use from this point kinda modified equation, because we can say that cosine x squared is just 1 minus sine x squared. And what we will get is just simply 1 minus 4 sine x squared is equal to 0. Sine of x squared is equal to 1 over 4. And sine of x is equal to plus minus x is equal to pi over 6 and 5 pi over 6. The second question, we need to find the derivative of this function. And again, for me, it was easier to find the derivative for this function instead of the initial one. What we will get is just 1. The derivative of 1 is just 0, so it's just minus 4 times 2 times sine of x over rule and multiplied by the cosine of x chain rule, and it's just minus 8 sine of x cosine of x, and it's just minus 4 sine of 2x. And we need to find out when the derivative is equal to 0. So sine 2x is equal to 0, x is equal to 0, pi over 2, and pi. Let's sketch the graph for the next question. So the maximum value would be 1, and the minimum value would be minus 3. intersects x-axis in points pi over 6, 5 pi over 6, and the derivative is equal to 0 in pi over 2 and pi. So our graph would look like this. And of course, it's the same thing here. But we need to sketch the graph of this is the module of f of x. So we need to copy everything that is below y equals 0, and it would look like this. And for the last question, we just need to solve this inequality. And as you can see, y is equal to 1 in this point on this line. So we need everything above. And it's just, we need to find this point. Okay, so we need to solve 1 minus 4 sine of x squared is equal to 1. Go to 2 over 4, 1 half. Sine of x is equal to plus minus 1 divided by square root of 2. X is equal to pi over 4, 3 pi over 4. So this is pi over 4. This is 3 pi over 4. And our answer would be from pi over 4 from 3 pi over 4. Moving to the next question. Consider a 3-digit code ABC. Find the total number of possible codes, assuming that each value can be repeated. So we have 5 possibilities for number A, 5 possibilities for number B, 5 possibilities for number C. It's just 5 times 5 times 5. 5 to the third power is 125. Assuming that no value is repeated. Then we have for A, we have 5 possibilities. Then for B, we have only 4 possibilities because one of possible values is already used for A. And for C, we have only 3 possible variants. And it gives us 5 times 4 times 3 is 60. Let p of x is equal to some function. Consider the case where p of x has a factor. Find an expression for p in terms of a. So what I would like to do, let's write p of x as you can see, this thing is x plus 2 times x plus 1. Okay, so we can write it like this, and x minus d. D is our third root of this cubic equation. Okay, so for a, it's just minus sum of all roots. Okay, and if we write this in the form that we can see our roots, it would look like this. And that is why I used x minus d. So here is minus 2 plus minus 1 plus d is equal to 3 minus d. Okay, and for b, we can, for example, we can just multiply all those factors. Or if you know, then b is just sum of products of roots. So it looks like this. And we can just substitute our roots into this. And this is equal to minus 3d. From this, we will get d is equal to 3 minus a. And we just simply put this expression into the expression for b. And what we will get is b is equal to minus 3 times 3 minus a. And it's just 3a minus 7. This is the answer. Now we need to show that is the only way to assign the values. Okay, we can also use the fact that the last number c is equal to product of our roots. It's minus 2 times minus a times b, and it goes with minus. So what we have is c is equal minus 2d, and because our only options for c is 2 or 4, because as we look here, of course c should be even, and the only even numbers here is 2 and 4. We can just look into two examples. So when c is equal to 2 and when c is equal to 4, then d is equal to minus 1. There d is equal to minus 2. But if we substitute d is equal minus 2 for our expression for b, we will get 8, which is more than 5. So it's not possible, right? So the only option is c is equal to 2, d is equal to minus 1, then b is equal to 5, and a is equal to 4. And that's it. Express p of x as a product of linear factors. We did this before, but we just need to put the value of d. And we can also say that this is just x plus 1, and it would be x plus 1 squared times x plus 2. And this would be kind of helpful for the next question, because we need to sketch the graph clearly showing the coordinates of any intercepts. Okay, so let's sketch a graph. Also, p of 0 is just 1 squared times 2 is 2. Okay, and this function, and if p of x is equal to 0, then x is equal to either -1 or -2. So let's put those points. So our graph would look like this. It doesn't change the sign in x equals -1 because it's an even power. Power of even number is going to be positive. So our graph looks like this, and this is the final answer. And the last question, we need to find an argument of z0. So first of all, we can see that n is equal to 0 for this case, and that is that 0 is just and our argument it's just arctangent of 1, and it's just pi over 4. Write down an expression for argument zn. The same thing, but you need to remember there's the argument, so use arctangent of imaginary part divided by real part. It's going to be arctangent of 1 divided by n squared plus n plus 1. Show that arctangent A plus arctangent B is equal to following equation. So we can take a tangent from both sides. Tangent of arctangent just cancels out. And for the left hand side, we can just use the tangent of a sum. So basically, it would be a kind of long equation, but you should know the formula. Basically, tangent of x plus y is equal to tangent x plus tangent y divided by 1 minus tangent x tangent y. And for our x and y, it's just arctangent A and arctangent B. Those tangent and arctangent going cancel out, and it will yield us this equation. You just kind of want to write. I hope you got it. Show that argument of W1 is equal to arctangent 2. We can use two approaches. I just want to show you other approach you can use, because the second one we will be using for the next question. So by definition, okay, W of 1 is Z0 times Z1. Z0 is 1 plus Y, and Z1 is 1 squared plus 1 plus 1 plus Y. So it's 3 plus Y. And it's just 2 plus 4I, and argument of V1 is just arctangent of 4 divided by 2, which is arctangent 2. And for the last question, we need to show by induction that the following equation is true. So let's start with the base of induction. If n is equal to 0, then V0 is just Z0, and we proved it for that argument of that 0 is just arctangent 1, so it's equal to argument of W0. Okay, so let's set if it's true that n is equal to k, and we need to prove it for n is equal to k plus 1. So we can write W k plus 1 is equal to wk times zk plus 1. And this is going to be useful in the next part. So argument of v k plus 1 is equal to argument of vk times zk plus 1 is equal to the sum of arguments of vk and argument of k plus 1 z k plus 1. And this thing is equal to arctangent k plus 1 by induction. And this thing is going to be equal 1 divided by, for n we substitute k plus 1, so it's going to be k plus 1 squared plus k plus 1 plus 1, like this. We proved this before, right here. So what we need to do is just simply add arctangent of k plus 1 and arctangent of 1 divided by k plus 1 squared plus k plus 1 plus 1. We just put dot dot dot, okay? And we can use the following formula. So it's equal to arctangent So we can just the numerator and the denominator by k plus 1 squared plus k plus 1 plus k. So what are we gonna get is k plus 1 times k plus 1 squared plus k plus 1 plus 1 and plus 1 divided by k plus 1 squared plus k plus 1 plus 1. It's a numerator, and in the denominator we're gonna get k plus 1 squared plus k plus 1 plus 1 minus k plus 1, and it's divided by k plus 1 squared plus k plus 1 plus 1. This and this are going to cancel. We will end up with k plus 1 times k plus 1 squared plus k plus 1 plus 1 and plus 1. And here it would be k plus 1 squared plus k plus 1 plus 1 minus k and minus 1. This and this are going to cancel. Also, k plus 1 squared plus k plus 1, it's just k squared plus 2k plus 1 plus k plus 1, so it's equal to k squared plus 3k plus 2. And let's substitute it. And k squared plus 2k plus 1 and plus 1, so it's plus 2. And here is k plus 1 times k squared plus 3k plus 3 and plus 1. And let's open up the brackets. So it would be k cubed plus 3k squared plus 3k plus k squared plus 3k plus 3 and plus 1. This is just k squared plus 2k plus 2. And what we can see is we can write it as k times k squared plus 2k plus 2. And this is going us to leave with 2k squared plus 4k plus 4. And the denominator will look the same. And this is just 2 times k squared plus 2k plus 2. So we can just cancel k squared plus 2k plus 2, and this will leave us with k plus 2. So the argument of wk plus 1 is equal to arc tangent of k plus 2, which is we needed to show. So our proof is complete. I hope you liked this video. This is my first video, so I hope the next video would be better in terms of quality. I would like to hear your feedback in the comments. Thanks for watching, and see you next time.